Okay, so I'm Paul Boys. I'm the community director of COVESA. COVESA is the Connected Vehicle Systems Alliance. COVESA is an open, collaborative, and impactful technology alliance accelerating the full potential of connected vehicles. Working together, we are a force multiplier, creating a more diverse, sustainable, and integrated mobility ecosystem. COVESA is all about the connected vehicle. So I'm going to do a quick introduction here. The Spotlight Series is a monthly series that we have where member organizations from the COVESA community present their use/implementation of COVESA's vehicle signal specification, answering the following questions: why VSS was used, the value of using VSS, how VSS was used, and what could be improved with VSS. And today we have RTI. They're presenting how Data Distribution Service, DDS, enhances VSS with a secure, full-stack, end-to-end real-time communication for software-defined vehicle. We have Neil Puthoff and Pedro Lopez Estepa, and I'll let them take it from here.
Thank you, Paul. So as already introduced, we are joining from Real-Time Innovations from RTI. My name is Pedro Lopez. I am the director of Automotive, and I am a member of the board of directors of COVESA as well. This presentation will be structured around two parts. The first part will be a more commercial and the reasons why we arrived to the conclusion, if you're not a member of COVESA or VSS, why we arrived to the conclusion that the journey reach VSS. And the second part, the one will be done by my colleague, will be more technical. We're going to be displaying a demonstration where we get the advantages of VSS and customers can leverage the unique capabilities of our DDS-based framework, given its data-centric capabilities. So for those of you who don't know, RTI, it's #1 software framework for autonomy. We have been here for a while. We have been in several industries, transforming complete industries like avionics, defense. Lately, in the last years, we are transitioning as well, part of our focus to healthcare, automotive, industrial automation that has similar problems that the industries that we have already transformed, and that our technology would be a great fit. We have been doing that already for several years, and we see already in those industries that our technology is starting to dominate certain aspects of the communication vehicle and other parts of the communication in other industries. The nature of our collaboration with COVESA is not a one-off. The motto of RTI has always been enabling interoperability through a rich ecosystem. And in order to do that, we have an extensive set of partners where we are not just having a logo partners, but we have a deep integration with the majority of them. Because from RTI, we really believe that the only way that the industries are fully and truly transformed is by the cooperation of the ecosystem. Not by proprietary solution, not by heavy acquisitions, but by having dedicated and key knowledge at different environments and making sure that to facilitate the ecosystem to cooperate and bring value at each one of the value chain. So let's start with the reasons why we believe that COVESA is the answer to one of the software-defined vehicles challenges and opportunities. So when we started to analyze like the opportunities in the software-defined vehicle, we could summarize them in a high level in 4 pillars. First, there is the opportunity to continually innovate. While some people see it as a challenge, we perceive it as a great opportunity. The vehicle development does not end at start of production. There are several functionalities that can be added once the vehicle are on the streets, and that includes ADAS, communication, and that's a huge opportunity for many vendors to jump into the vehicle, not during the development cycle, but even after development cycle. There are severe cost savings. So for the OEMs, there's a huge opportunity to invest what you are saving in wage and cost, because the E architecture represents the third heaviest part of the vehicle. If you simplify with the new modern architectures, you can invest much more on differentiating at the software level. Because of that, new business models are opening opportunities, new revenue streams from application level. to solution level. And that's something that the traditional model did not allow. And then there's an opportunity to compete. There's not like the big brands having a monopoly around the development of the vehicles, but there's an entry barrier that the electric vehicles have made clear to the industry, where you can reduce the entry levels for a solution. You could potentially make a deal with a large traditional OEM to sell in the secondary market a solution, a fleet of vehicles based on your solution. That's something that is completely new and create a level of competition to differentiate that has not been there before. But opportunities translate into challenges, and there's a challenge in terms of scalability. The system's complexity, while the wiring might be less, the scalability that is required in order to enable some of these functionalities, it's never something never seen in the industry before. The level of standardization, it's really a problem, and we will touch bases because that's one of the biggest advantage that VSS will have into the whole picture. The level of standardization, if you look at architectures between vendors, the levels of hardware standardization in order to reuse a lot of the software vehicle signals is minimum in the data models, in the signals, and that makes it a huge challenge to have a solution that you can replicate in different vendors. The cost, liability, and warranty, the software bill of materials are not yet standardized. There are a lot of discussion about software bill of materials, but that's not something that is widely and broadly implemented. And that makes it really hard to understand what's the value from a vendor on my particular software solution. Security and safety, cybersecurity, while ISO 26262 and ISO 21434 are terms that are well established in the industry, there are a lot of assumptions done. There are safety elements out of context. There are analysis, corporate and product analysis in development phases. There are a lot of questions, and you cannot compare one-to-one yet what's a product is offered by the supplier A and the supplier B, even though most of them might be ASIL-D and both products might be certified by the same TÜV organization. It's really hard, and it's only until you go into the low-level details of the safety manual that you realize, okay, we can compare apples to apples. And the last challenge in the high level is building L2 plus sustainable development. I know there are many vendors that are going L3, L4, L5, but already we see like there's a trend in the industry focused on L2 plus, and having sustainable development, including over-the-air updates and everything that has to do with it, is not simple. So how we see these challenges being translated into the requirements that the architectures in the industry need to formalize are the software-defined vehicle architecture need to comply with 5 big pillars. And that's a realization that we had after many meetings at many consortia and at many OEMs. There are many more, but we consolidate the top 5, at least from a software level as a middleware, like our case. You need to be flexible deployment. You need to have certain level of standardization, need to be decoupled from the platform, enable future-proof, and safety and cybersecurity. Because of the nature of VSS, in this presentation, we are going to be focusing on the decoupled from platform, future-proof, and the standardization. But we have, if you're interested, you can reach out to us and we can talk more in detail about safety, cybersecurity, and flexible deployment. So when we are working with many of the OEMs, they don't care. They just want to connect. They don't care if there's an application running on an Oryx Tricore on classic AUTOSAR or with a given RTOS, safe RTOS, that or another one which is working on AUTOSAR Adaptive on ARM or Android in the infotainment on the digital cluster, or they have a traditional application running on QNX, or they have a cloud-based application running in the cloud, or you have a hypervised environment, a container-based environment. They just want applications, and those applications might be moving today from a low-level ECU to a later on to a digital cluster, or even all the way to the cloud. So you need to decouple the application from the platform. And that's a requirement that these kind of architectures need to have from day 0. Another one is standardization. we arrived to many OEMs that the different teams are not talking to each other, and the description of signals which are well established in the industry is not simple, and somehow they see value on differentiating in the signal level. But could we imagine a common standard, a data model for all of them to have them in an RFQ and reduce the complication levels? So the architectures that we see and many discussions that we have need to be standardized, so the software providers, the value providers can really focus on differentiating and not going on the low-level architectural details. And the last one we wanted to talk is future-proof. We are having designs with code, application code in AutoSAR Classic, 10 years old, 5 years old, new integrations with AutoSAR Adaptive, application in ROS to native applications in technologies like ours, like DDS. All of these need to work, and you need to have a door for the future open integration, cloud-based development, or any application running in the cloud. So all of this consolidate the view that we have on the industry, like 5 big pillars that every software-defined architecture need to keep in mind when they start designing. And when we were going over this with many customers and analyzing the market, we realized like, will it be great that an organization will touch or will try to help these 5 pillars at least partially? And that's why COVESA came into our radar, and VSS in more particularly. What are the benefits that from our end, from a middleware provider, we see on COVESA VSS and on VSS in particular? First, we map it to what we have seen before. VSS is a flexible, enable a flexible development, deployment from in-vehicle to the edge and the cloud. One of the big pillars that we have been identifying, you cannot lock an application to a certain location. You need to be able to deploy wherever the architecture fits best. It provides a standardized communication, common approach for describing vehicle data. While this might be trivial, it's not. We have vehicle vendors that are describing signals in a custom or proprietary way, and that's reduce a lot the effectiveness of the integration and go-to-market capabilities. Is decoupled from the platform, is protocol agnostic. We are providing a protocol, but VSS is in a way that an RFQ could call VSS or could call an architecture like this, and then the vendor will use DDS if it's the one that considered the best. And we are trying that this is the case, but it needs to be decoupled from the platform. So there's nobody in the industry that can map it like, okay, you are driving the industry in a certain direction. It's cost driven. If we go back to the reasons why the vendors are using these new architectures, the money should be in the differentiation. It should not be in the low level architectural decisions. And that's something that while the industry is starting to realize, it's a huge saving from the cost perspective. And then interoperability. There are open discussions with other consortia like AutoSAR and other standards to guarantee interoperability. And technologies like ours, like DDS, is particularly important in order to do that. So those benefits were clear to us. It took us a little bit of time because the complexity of VSS, it's not a concept that you get the whole picture of COVESA right away, because if you try to analyze it, it's really broad. But we have been clearly identifying this as a huge added value for companies like RTI. So what has been our contribution? We are basically right now, in addition of being part of the board, we are working on 3 levels. We are working on the vehicle signal specification, trying to enable customers to use DDS, and that's the part of the technical integration that you're going to see in this presentation. Neil will present a real demonstration of how DDS enhance the functionalities provided already by the standardization of VSS. We are working with AutoSAR interoperability, bringing VSS and AutoSAR. For the audience, we have one of our members, Emilio Guijarro. He's part of the working groups that has standardized AutoSAR Adaptive and AutoSAR Classic DDS integration. So we are in the best position to support and facilitate this integration. And last but not least, we have been working with Digital.Auto to accelerate vehicle prototyping. We displayed that at Bosch Connected World last year, and we intend to continue working on that front. So now that we know why VSS, then why ConnectDrive, which is our product, and why DDS, the technology that is based. So for those of you who might be new to DDS, DDS is a standard, which is, again, one of the key values. When you are working on a technology underlying on a standard like VSS or a signal specification, if you may, to be more concrete and more precise, it needs to be a standard. You cannot place a proprietary technology underlying, because at the end, then you kill the value that VSS is providing. So DDS is a standard which is standardized by the OMG, which has other industrial protocol like UML or DDS, Industrial Internet Consortia, and there are several implementations. That's extremely important as well. You cannot have even though if it's a standard, you cannot work under the perception of a standard that only is supplied by a single vendor. So it's important that there are several implementations of that standard in order to consider it valuable for an implementation like VSS. Why the industry is starting to realize DDS is huge value for integration like VSS? First, because it's modular. The nature of the technology is data-centric, it's modular, it's scalable. So if you look at the specification of VSS, it needs a level of scalability. You don't know from the beginning how many sensors you're going to have and how many signals you're going to have. So you need a technology that can accommodate the scalability requirements of VSS. It's highly reliable and maximum uptime in terms of resiliency. So it's extremely important from the vendor that the resiliency and the performance are there, especially when you are talking about communicated vehicles. The development and the time to market, we are working, and you will see the demonstration by Neil Butthub, where you will see how fast it is to develop based on our solution and a VSS model. The code can be reused, and if you think about the original intent, the applications should be moving. Either they are in vehicle or edge or at the cloud, you should be able to do that. And last but not least, and this is extremely relevant, especially when you come to an industry like automotive, you should be able to work on a standard base where you can have a no vendor lock-in and a future proof. So it's when we're looking at the vendor-driven organization, that's the key value from us. We are commercializing this technology in a framework which is ConnectDrive, and that's what you're going to see in this demonstration. You're going to see an automotive grade software based on the standard DDS, which can provide features from the low-level ECU to the edge and all the way to the cloud. Is future-proof because the data centricity architecture allows you to move libraries from low-level ACLD C code to Intel-based C++ or Java at the cloud with a complete solution based on ISO 26262 up to ACLD. The examples that you're going to see in this presentation are going to be focused on zonal and ADAS application, a little bit of digital cockpit, but we will have applications to enable OEM custom applications, telematics and cloud, and even simulation. And we have interfaces to other technologies such as ROS to AutoStar Adaptive or AutoStar Classic. With that, I want to summarize the content shared until now. The industry is going on an unprecedented challenge as we are opening the doors to massive software implementations. In order to do that, you need to identify clear how we are going to solve the key challenges that we have already described in order to leverage the opportunities. The best way to do that is consolidating everything that is not differentiating, and that the value is that this is standardized and globally implemented, and that's what the value we see in VSS and the level of agnosticism and standardization that it provides. And then you will need to be able to select technologies. We believe the best technology underlying is DDS, and we see already a general trend that agree with that statement. And we hope that you will enjoy the following demo, where we intend to show you why the value of DDS is extremely visible already for the OEMs that are starting to work with us. With that, Neil, give it back to you.
All right, Pedro. I'll share my screen, which will pick up where you left off. There you go. How's that working? Good.
Perfect.
Okay. So moving forward, I'm just going to do a recap of data centricity. And with a data-centric communications interface, the data itself is the interface. And as a software engineer and system developer, that is really convenient because I don't have to deal with message wrappers or protocols or anything like that. I just deal with the data. So I'm either receiving this data or I'm populating a struct and sending it out. So it's a publish, subscribe, and there's also request reply patterns as well. What's really interesting about this, though, is if you have a data-centric communications architecture, and if you have a common set of data types, like the COVESA VSS, putting those two together, it guarantees interoperability. It makes it, as Pedro said, where you can have multiple suppliers and you can build this expansive ecosystem of tools and packages and ready-made capabilities that are just available and known to, beforehand to interoperate. And this is something that has, that COVESA is doing, but it's also been embraced by other organizations. And I've got just a few of them listed here. The ones on the right-hand side, they're more military applications, but they are things that move, so I thought they were relevant. But what's interesting about this is two things. One, all of these standards operate on DDS. So if you were planning on making a, like a semi-aquatic vehicle that could also fly, that can take the kids to school and also head off into battle, DDS would be the integration technology that can tie that all together. One other piece that is really interesting is if you look at ROS, the robot operating system ecosystem, what's interesting is they have for a long time had a defined data model or set of data types. That is their interoperability and the basis for their expanding ecosystem. So I look at what COVESA is doing with the VSS as akin to what ROS has accomplished in enabling this expansive interoperable ecosystem. Is everyone standardizes on the same data types and presentation, and then things just work. So it's really convenient that way. So I've already made that point. All these run on DDS. So looking at a closer look at the COVESA VSS and how it works with DDS is you take the VSS spec files, and they are essentially they're a collection of files that are organized in a tree structure, and it's specified in YAML. That's the format that it's in. A sister repository to the VSS spec is the VSS tools spec, and there are converters to convert this into things like CSV or JSON, or in this case, OMG IDL, which is interface description language. That is the underlying data description language that's used by DDS. Then the individual DDS vendor will use their own code generator to turn this type support code into the language of your choice and potentially operating on the operating system and platform of your choice. And what I have listed here is just what's available from RTI. There's a huge amount of support, and this isn't even an exhaustive list, but it clearly it makes it to where whatever your preferred environment is, maybe you're going to be doing some things in MATLAB or in SCADE, it can all work on the same common ecosystem that is using COVESA VSS types and running on DDS. So it's really convenient, for a developer point of view. And also there's already a very expansive ecosystem available for COVESA, which is pretty exciting. Now, what I'm going to show you today is a demonstration that we had shown at the CES show in Las Vegas back in January. And what this is essentially it's the innards of a software-defined vehicle, and we had it pulled out across several kiosks on a variety of platforms. We had some from from NXP for doing some front-end processing, a big box from NVIDIA for doing some of the heavy lifting. Down at the bottom here, we had several boards from Infineon that were running AUTOSAR Classic, and even some for some telecommunications boards from Renesas. Architecturally, this resembles the architectural block diagram that's outlined at the AVCC, the Autonomous Vehicle Computing Consortium, in their technical publication TR001. There's a recommended architectural block diagram. And just a note about the arrows, what I used at the show was I had a gaming laptop that was running an autonomous drive simulator. It's called Carla, and it has a ROS topic bridge. that will take some of the internal data structures in this simulator and turn them into ROS2 data topics, which are on DDS, and they are then made available to the system. The topics are in yellow, are more aligned with the ABCC data types. And then, of course, COVESA is used for all the reporting of what's happening inside the vehicle. What's interesting about this, though, is, I mean, putting together a system like this, it may look fairly complex. It was at the end, it was involving probably close to 14 or 15 individual computers, counting the demo laptops there. And it was put together with a very modest development team. It's something that I put together in a matter of a few weeks for the entire demo, but it was up and running on essentially the first day. And the reason for that is having available data types. It's really easy then to define your applications to say, okay, it's going to get this data type in, it's going to be LiDAR, cameras in, and I'm going to be reporting topics out or processing things and sending them to another module on a different predefined topic. So it makes developer life very easy to get things up and running. All right, so what we're going to do is I'm going to switch over now to looking at the live demonstration. And I'm going to do that by what I have here behind me in my slideshow. What I have behind me running is I have that gaming laptop running behind me, and it's running the Carla simulator. I don't have the remainder of the boards that were used for the COVESA demo or for the CES demo. They were needed elsewhere. So the majority of this system is running on the gaming laptop itself. And just for a quick look, what I'm looking at here is what we call our admin console. And this is a piece of test equipment. It's an application that we have that it displays what the topics are running on the system. So here on the left-hand panel, there is a list of all the topics. And for the COVESA data types, I've prefixed them with the letter C. So they correspond to the various categories in the COVESA VSS. There's also, a number of ROS topics and some internal topic types. ROS generates a lot of topics, so the list gets to be a bit long. And some of the internal types are in here. And at the bottom, it's a list of what the system looks like. How many RTI G7 is the G7 gaming computer. This is my own laptop, and it says what processes are running, what the IP addresses are. If I select any one of these topics, then it can see who's publishing and who's subscribing. And clicking on any of these, I can see not only what the data type looks like. So this is a COVESA vehicle body state topic. And it includes things like, is the hood open, the status of the trunk, the horn, the mirrors, but also what's the quality of service settings on this particular topic. So I can say that it's got, we're presenting by instance, it's got volatile durability. I'm sending it, let's see, go down to the bottom here. And so type coercion. There we go, reliability. So I'm sending it reliable, and that's one of the things that that DDS has available for it is a huge variety of quality of service settings that really means that DDS can make a application work in places that TCP or UDP alone cannot, because it has such extensive quality of service, where you can set things like timeout and resend and liveliness and persistence and durability and all of these things. Now, what's interesting about this particular application is not only can you view what the data types are and what the quality of service is, you can also individually subscribe or publish to these discovered topics. And that is another interesting point, is that part of the DDS protocol is this concept known as discovery. So when you publish or subscribe a particular data type, it makes an announcement and discovers other publishers or subscribers of that same type. Part of the announcement is the data type, and part of it is the topic name and the data type name. So on the fly, without any knowledge of what a data type looks like, we can actually discover what that is and even subscribe to it. And in this data view capacity, I'm subscribing to one of the topics that is reporting data from an IMU from the simulator, and I can graph it and look at what its values are on the fly. And that includes, the different angular orientation, angular and linear velocity and acceleration. which from a system visibility perspective compared to, you know, a packet sniffer or that type of thing, it's really, really convenient. This is a go-to tool for finding connectivity problems. In fact, you may notice that on the side here, there are some yellow indicators, and that's just a warning that says this is a reader-only topic, which means that a subscriber has been created, but there is no publisher for it. So it's not an error, but it is just a warning that says you've got a single-ended topic here. If there were an actual error, it would show up in red. That's one of the nice things about DDS is if there's a problem in connectivity, it'll refuse the connection, and a tool like Admin Console will immediately flag it. So you can't ship something with potential connectivity problems. What the IDL looks like is something like this compared to what the VSpec files look like. So it ends up, the IDL code generator ends up making a structured representation of the types that also reflect what the tree looks like. So for instance, this is at the very top end of it, where you can see what the version of the VSS is, you know, in terms of, you know, integer numbers of major and minor, revision numbers, space for the VIN number, and also details about the vehicle. But it is a very expansive specification that has lots and lots of data types. This is everything combined into one view, but these can also be put into individual IDL files. But as done like this, it'll compile it into a set of data type support files, and you can turn it into a library and then pull the ones that you need. So really convenient. And I think what we're going to do is now switch over to open discussion and see if there's any questions about things. I'm going to hand it back to you, Paul and Pedro.
Yeah, please ask questions if you have them. Thank you guys for doing this. Much appreciated. Any questions?
Yeah, even I would say we are using the RTI products, one of our, I would say, preliminary development, but still, do we have this IDL to or VSS signal specification to IDL generator available that we can, let's say, experiment and see what we try to do like in the current development?
Yes, the IDL generator is part of the VSS tools repository. What I would say about it, though, is in its current state, it does generate IDL, although it takes the individual signals of the VSS spec, which there are about 850 of them at the moment, and turns them into individual topic structures. So it's very, very granular, and there is work underway, and that's the work that I'm doing to group the signals into usable topics. So for instance, that also respect the tree structure of the VSS. So for instance, if you've got like a GPS coordinate thing, you don't have individual topics for X, Y, Z, you know, latitude, longitude, altitude, but they are grouped together as a single entity. So that's something I can share with you early if you'd like just the IDL. You know, and I would say just use it provisionally because it's as yet not committed to the repository.
Yeah, Kamlesh, we will make sure that our sales channels open discussion about this.
Okay, yeah. And even I would say when we have this IDL to ATOSR connectivity, means we are already using your product called RTI integration toolkit in for our ATOSR integration portfolio, but still if you have this kind of solution already available, how we can use the IDL to ATOSR integration possible, that will be good to know. Thank you.
Questions? I have a general question. How do you guys see, I mean, you talk about data centricity and data allowing for change. I mean, what are some of the big, you know, for the SDV, I mean, updatability is a big part of that, being able to change what you've done and, you know, as you grow and learn. How do you see that? Just can you give some examples of why that works, of how that works, and what you've seen work and not work, if I'm making any sense?
Are you asking like how does having a predefined data model that everybody can point to, how does that enable things to happen.
Yeah, I'm just maybe some specific examples of like what it has done where you've seen it succeed and just or where it hasn't worked.
I mean, I think that the most glaring example is the ROS community, or it's certainly the easiest, where there are now, I mean, thousands of packages available that all conform to a common data model, and it's used for robotics. And ROS, it's intended to be a robotics research, not necessarily a production automotive. I wouldn't necessarily recommend it for that use case. So I look at COVESA as the VSS as being poised for that same sort of community effort where, if there is data reductions that can be done on position in the vehicle or any of the metrics that come from the VSS, it could be pretty easy for a supplier of this technology to just package it as a, ready to go software module that takes VSS signals in, puts out, some other form of derived intel from it, or, as a control system or what have you. It's just a way of making useful components within the vehicle or for off-vehicle export, starting from the same set of terms, which is using the VSS. So it's, it really does enable a marketplace and ecosystem.
If I may, if a customer of ours come, Paul, and they're looking at DDS and they have a traditional infotainment use case, maybe the data centricity might be an overkill. So it's the integration and everything. Maybe they feel like, okay, we can do that with so much. We can do that with other lower level technologies. They are not getting the whole leveraging of the whole solution. But that's kind of low level infotainment systems, and COVESA is an evolution from Geneva, and Geneva has been evaluating DDS in the past for some of those use cases. It's not there anymore. They are more like digital clusters that are connected to a zonal architecture. And there's where the product has been shining. The first thing it was when the zonal architecture started coming, platforms like NXP S32J, connecting with Tricore, with a variety of operating systems, AutoStar Classic and the ECU AutoStar Adaptive or QNX or other kind of variety of compilers, then data centricity had a lot of sense, because especially if you are thinking about a model where you might have 3 or 4 variants with different assembly line, having the possibility to define the vehicle in a data model way, in a data-centric way, it's extremely valuable. Then when the digital cluster team was designing, and we see this, the natural course of things is the digital cluster people start working on it, and there are stacks there from proprietary stacks, BlackBerry ID or TomTom or other stacks. They come to us and they say, hey, we want to plug into DDS because it makes a lot of sense to have access to VSS, for example. It has a lot of sense to have access to a variety of signals that are talking already in a data-centric way with DDS. And then that perception, even from the digital cluster or from the infotainment, change. In the telematics part, in the telematics control unit, the ADAS obviously as well. ADAS, zonal architecture, all in one's huge value for data centricity. In the telematics, not all the use cases, especially when you have MQTT or other kind of communications, DDS is not always a match, but in real-time operation with a variety of conditions over wide area networks, we are perceiving more and more, and maybe for agricultural construction and mining, maybe for use cases more and control that need maybe teleoperation, which they are ahead of the industry. We see as well data centricity having a lot of value. If you are going to have category M1 or a narrowband IoT for once a day, the telemetry position, obviously not. Data centricity might not be your thing. But beyond that, we see an unstoppable expansion of DDS and data centricity in the vehicle. I hope that answered your question, Paul.
Yeah, this is good. Any other questions?
So I wanted to ask a question about security. And so looking at VSS and is dealing with signals, these are very low level data components. They run on ECUs, they're not very powerful and so forth. What types of security features at DDS do you see actually being implemented on these ECUs that will handle signals?
Well, I would take that as let's start with the DDS specification itself, where as part of the spec and the published documents, there is a plug-in security architecture. And DDS takes a slightly different approach to security where we secure the payload, but not necessarily the transport. So you can, on a per data flow basis, authenticate, encrypt, and have access control over your data topics. So you can do things like, you know, the time of day or the weather. You don't need that encrypted, but you certainly want it authenticated, for instance. And you can do things like, you know, mix secured and unsecured traffic on the same network, or do things like if you have an unsecure network, be able to secure the data that's going through it. And it also, if you are using a secure network like TLS or you know, or SSL, it ends up where you have a layered security architecture. Now, moving that down to the ECU level, it really depends on the capacity of the ECU and, you know, which libraries can it support. Typically, we will go with OpenSSL. We also have integrations with Wolf SSL for our security, for the security plugins. So if your ECU is capable of running either one of those two platforms, then, you know, things are good.
And in that front as well, to complement Niels' statement, there are different OEMs that might have proprietary integration. So that's, if you remember our presentation, we have OEM, custom OEM interfaces. DDS has a standardized DDS security capabilities. But in addition to that, we have certain OEMs that have particularities on their integration, and we work with them in order to facilitate or create custom-based integrations.
Other questions?
Yeah,
Go ahead.
perhaps can you help me on the slide you have shown with the block diagram on this CES showcase? You have shown that there is the motion controller on Infineon TC2. Can you elaborate a little bit on the resource consumption of DDS and your implementation?
See, in that particular one, it was running AutoSAR Classic on our micro platform. And just keep this in mind about DDS is that it has, you know, most of what's in the library is concerned with things like discovery and implementing the quality of service, and to some extent security if you have that in place.
Download the Rocket Source app.
The actual data sending is a really lightweight part of DDS. It's more about facilitating and ensuring quality. So data send in DDS is very, very fast. It ends up generally taking whatever the shortest pathway is, and it's, you know, barely above what you can do with just a regular socket or a shared memory transport. In terms of resource consumption, on a micro implementation, you know, we're talking about a few hundred kilobytes of code space, and there's, you know, going to be a certain amount of RAM as well to support things like the buffers for reliability. It depends on what you're on how you're using DDS, you know, to what extent you're trying to like allocate buffer space for history or reliability or persistence, you know, so it just depends on implementation. But it's not appropriate for things like you know, a small microcontroller that has 16 KB of flash space. It just won't work there.
Mr. Henkel, we have this information in the TC297 and in the TC3 to the low-level details on performance on different setups, but it's something that we can deliver under NDA. So if you're interested, we will be happy to set that NDA because of different reasons. So we are more than happy to share that information with you in a separate in other communication.
Okay, you're welcome. Perhaps we can meet in Porto so we can have a short talk there.
Perfect. So we will make sure that we are communicating and then we can directly interface. We have a report where what Neil explained at high level, non-confidential, goes down with the high level description of the performance in TC2 and TC3, and we just received the TC4. We can do it as well for the TC4.
Yeah, thank you for sharing. I'm looking forward to meet you in Porto.
Same.
Other questions? I have a general question, just your observations of where VSS can improve. I'm sure there's lots of places, but just, yeah, what do you see as like needed?
I'm going to preface this comment with just prior to working with COVESA, I had spent some time working with Ross. I tend to keep bringing it up. There is an abundance of monitoring topics available in COVESA. There is room for growth in things like control topics, for instance, control data types in COVESA. It's really more about completeness within the vehicle. And I think there's a really good opportunity to expand and maybe do it in a two-tiered approach where, there are part of the VSpec or, that of the release VSpec, or here's all the, monitoring topics for every part of the vehicle. And then there are some that are like more early growth, like some of the questions that came in earlier about how do you specify like lists of objects, or how do you do LiDAR, different sensors? How do you how do you do things like firmware updates? Another area for possible growth is in the metadata about the vehicle. Like you have a temperature sensor in the vehicle. What's its manufacturer? What's its temperature range? What are the the units? How many hours are on this particular sensor? That sort of thing. I mean, these are all things that a implementer would otherwise need to do themselves, that having essentially a grocery store of data types is, I think, a great use case for COVESA, and I'm looking forward to pushing in that direction.
Questions from anyone else?
I had a question about the topics problem that you mentioned. So you mentioned that VSS as it is right now is very granular, and it would be great to reduce some of the granularity by grouping things into topics. Do you expect that these topics will be standardized, and would you be the ones defining what the topics are?
I would say I would expect it to be standardized. It sort of is implied by the structure of the VSpec files, because they're already in a tree structure with branches and different nodes that have different things grouped together. So that really implies the structure. How that gets used depends on which code implementation. There are some implementations that really support a granular approach, like the GraphQL implementation. You can just present a laundry list of individual data elements that you want, and it'll return them in bulk, for instance. Something like DDS, where you're operating in a more constrained or more safety critical environment, where performance is also key, you're going to want to have defined topics, and not something that's quite so wide open. So in a DDS implementation, yeah, I would expect it to closely follow the tree structure as far as defined topics goes. Does that make sense?
Yeah, great, thanks.
Is there anyone else? Neil, you mentioned a semi-aquatic flying family mobile. Where do you get these?
I think if you eat a bad meal or something and then go to sleep, it's a car maker's worst nightmare.
Okay, well, I mean, if no one has any other questions, I really appreciate you guys doing this. Thank you for taking the time. It's much appreciated, and thanks for your involvement in working on VSS.
I just wanted to reinforce, Paul, thank you from RTI. And if anybody has any questions, I'll be attending the Porto AMM. So if anybody want to reach out to me, it's pedro@rti.com. You can reach directly. Neil will not participate in this one, but we will be in the one in November or end of the year, whatever that is in Dearborn or in the US, whatever will happen. So please don't feel free to reach out to us, and we're looking forward for VSS to be a reality, hopefully in production program in the following years.
Great.
Thank you, Paul.
Thanks, everyone.
Thank you very much. See you.
Bye.
See you.
Everyone.